This is the test 4.2 review, 3D figure, surface area, and volume. Number 1. The Central Cinema Theater sells popcorn in 2 different containers as shown below. The conical container sells for $2.50 and the cylindrical container sells for $3. Problem A. What formula would be used to find the volume of container B? Container B is a cylinder, so the formula for the volume would be volume equals area of the base times the height. Problem B. What formula would be used to find the volume of container A? Container A is a cone, so the volume formula is volume equals 1/3 area of the base times the height. Letter C. Compare the volume formulas for the 2 containers. What relationship do you notice between the volume of container A and container B? Answer in complete sentences. So if I'm looking at container A and container B, I notice they have the same diameter and they have the same height. The only difference is one is a cone and one is a cylinder. So if I'm looking at their formulas, I notice that if the cone and the cylinder have the same height and radius, the volume of the cone is 1/3 the volume of the cylinder. Okay. So if they share the same height and they have the same radius, the volume of the cone is 1/3 the volume of the cylinder. Number 2. How many square meters of wood are needed to make the storage container below? So because we're building this, we're going to be finding the total surface area. Start by highlighting your base. So our base is this rectangle right down here. So once you know your base, you need to find the perimeter of the base and the area of the base. So the perimeter is going to be 2 times 18 plus 2 times 12, which is 60. The area of the base is going to be 18 times 12, base times height, which is 216. The height of my prism, distance between the bases, is 9. So now that I know those, I plug them into my surface area formula, pH plus 2B, which is 60 times 9 plus 2 times 260. You multiply that together, you get 972. So your answer is 972 meters squared. Number 3, find the lateral and total surface area of the figure shown below. So this is a cylinder. So first we need to find the radius, which is half of 4.8. So divide that by 2, and we get 2.4. And we need the height, which is 14. Plug that into your formulas. So lateral surface area, 2 pi r/h. So 2 times 3.14 times the radius, which is 2.4, times the height. Multiply those together, you get 211.01 meters squared. And then to find the total surface area, we're going to take the lateral. So 2 pi r/h, and add the 2 bases, 2 pi r squared. We already know the lateral is 211.01. We're going to add 2 times 3.14 times 2.4 squared. Multiply that together, you get 247.18 for your total surface area. Number 4. How much frosting is needed to frost the cake below? So when we're frosting a cake, you need to cover all of the sides in frosting except for the bottom. So we're going to use the total surface area formula, but instead of 2 bases, I'm only going to need to add 1 this time. So the bottom of my cake, that's the base. So we need to find the perimeter of that, which is 14 times 4, which is 56. The area of the base, which is 14 times 14, which is 196. And the height of my prism is 14. So now we plug those into our formula. So we're going to do 56 times 14 plus 1 times the area of the base. So 56 times 14 plus 196 is 980 inches squared. So that's how much frosting we would need. Number 5. Name the type of surface area and the formula and which figure the formula is used for. So number 1, this is total surface area for prisms. So rectangular prisms, triangular prisms. Number 2 is lateral surface area, also rectangular and triangular prisms. Number 3 is a little bit tricky. Surface area equals pi times the diameter times the height. Pi times diameter is the same as 2 pi times the radius, and then times the height. So 2 pi RH, that's lateral. This time for cylinders. And then number 4 is total, also for cylinders. Number 6, match the definitions with the terms. The sum of the areas of the faces of a solid, excluding the bases. So not including the bases, that's going to be letter B, lateral. We do not include bases for that. The number of square units enclosed by a figure, that's just area, base times height. The sum of the areas of all of the surfaces of a solid, that's total, all sides. What do these variables stand for? P, perimeter of the base. So the base of your prism, the perimeter. Capital B, area of the base. R, radius. H is height. And B, this is base for when you're finding the area of the base. So base times height. Number 8. Mrs. Edmond needs to cover her Diet Dr. Pepper can by creating a new label for it. How many square inches of paper will it take to cover the curved surface of the can if the height of the can is 4.5 inches and the radius is 1 inch? So anytime you see curved surface, you're looking to use a lateral surface area. Okay. So we're going to use lateral surface area formula 2 pi RH. So pi is 3.14. My radius here is 1, and the height is 4.5. Multiply all that together, 28.26 inches squared. Number 9. The coffee can below is 3/4 full. how much coffee is in the can. So here, that's volume. We're going to use area of the base times the height. We know that the coffee can is only 3/4 full. So to find that height to use, we're going to take 8 times 3/4, which is 6. So for my height, we're going to use 6 instead of 8. My base is a circle. So to find capital B, we're going to use pi r squared, and then take that times the height. So 3.14, my radius here is 3. And my height, we just said we were going to use 6. Multiply those together, 169.56 inches cubed. Cubed because we're doing volume, not surface area. Number 10. What is the volume of the figure shown below? We're going to go through all of these steps to find that. Start, name of the object. This is a cylinder. Shape of the base, circle. Outline the base with a highlighter. There's your base. Formula for the volume of the cylinder, that's what we just did. Capital B times H. Formula for the area of the base. It's a circle, so it's pi r squared. Solve for the area of the base. So we're going to do 3.14 times 4.25 squared, which is 56.7. That's the area of our base. The height of the prism is 6. And now we just have to take these two numbers and plug them into our volume formula. So we're going to take 56.7 times the height, which is 6. 56.7 times 6 is 340.3 feet cubed. Because, again, volume, you can use cubed for your units. Number 11. Samuel wants to make a miniature version of a full-size tent. The divisions of the tent are shown below. The ends of the tent are isosceles triangles. The canvas costs $2.15 per square foot. How much will Samuel spend on the canvas to make the miniature tent? So we're finding total surface area here. The base is this triangle. So we're going to find the perimeter of that. 1.5 plus 1.5 plus 2, which is 5. Next, we need to find the area of the base. Because my base is a triangle, we're going to do base of the triangle times the height divided by 2, which is just 1.8. And then H is the height of my prism. So not the height of the triangle, the height of the prism, which is right here. 3 feet, the distance between the bases. Plug that into your formula. 5 times 3 plus 2 times 1.8. Multiply those together, you get 18.6. So that's the surface area of my tent. But if I go back and reread the question, it says, how much will he spend? So I need to take my surface area and multiply it by how much the canvas costs, which is $2.15. So my final answer would be $39.99. That's how much you would spend to build this tent. Number 12, find the volume of each. So this is a sphere. So we're going to use 4/3 pi times the radius cubed. 4/3 times pi. My radius here is 48. And then you're going to take that to the third power. Multiply those together, you're going to get 463,012 millimeters cubed. Next, we have the cone. Formula, 1/3 base times height. My base is a circle, so 1/3 times pi r squared times the height. So 1/3 times 3.14. My radius here is 4. They gave me the diameter. So I'm going to do 8 divided by 2, which is 4. And the height is 12. Make sure on your test tomorrow you're using the fraction 1/3. Do not type in 0.33 or you'll be counted wrong. You need to use the 1/3 fraction. Multiply that together, you get 200.96 inches cubed. Number 13. Your drink from Sonic leaked into the cup holder of your car. The cup holder has a height of 2 inches and a diameter of 4 inches. Your cup has a diameter of 3 inches. What is the maximum amount of vanilla Coke that could leak out of the cup before it spills over the edge of the cup holder? So we're looking for how much the cup holder can hold. So we're going to be finding volume. So start by finding the volume of the cup holder. So it's a cylinder, so base times height. The diameter of my cup holder is 4, so the radius is just 2. So pi r squared times the height. And then the height of my cup holder, I said, was 2 inches. So multiply all that together, and we get 25.12. So that's how much volume the cup holder has. Next, we need to find how much volume our cup is taking up. So our cup is also a cylinder, so it's the same process. Pi r squared times the height. They told us the diameter of our cup is 3 inches. So the radius, we're going to use 1.5. So we're going to do 1.5 squared times the height. We're going to use 2 again because we only need this part of the cup that's sitting inside the cup holder. So multiply all of that together, and we get 14.13. So we know my cup holder holds 25.12 inches cubed. The cup takes up 14.13 inches cubed. So to find the amount of soda that could fill the leftover space, we're going to take 25.12 and subtract 14.13 from it. And you get 10.99 inches cubed. That's how much soda could spill out of the cup before the cup holder overflowed. Number 14. If point A, -32, is translated under the rule negative x minus 5, y plus 1, what will be the new coordinates of point A prime? So to solve this, we just have to take our x and y values and substitute those into our rule. -3 minus 5 and 2 plus 1. -3 minus 5 is -8, and 2 plus 1 is 3. So those are the coordinates of A prime. Number 15. What algebraic rule describes the translation of triangle ABC into triangle ABC prime? So we're going to look at our triangle, pick a pair of points. we're going to find out how they move. So I'm going to go from B down here to B prime. So over 1, 2, 3, 4, 5, 6, 7, 8. So we went right 8 and down 1, 2, 3, 4, 5. Okay. So right is going to be my x. So remember, algebraic rules start with x, y, your arrow. If I go right 8, that's adding 8 to my x's. And down 5, we'll take my y's, and we're going to subtract 5 from those. So this would be my algebraic rule for that translation. Number 16. Triangle PQR is reflected over the y-axis. The coordinates of point P are -3, -1. What are the coordinates of point P prime after the reflection? Write an algebraic rule to represent this transformation. So if we're reflecting over the y-axis, my algebraic rule for that, we're going to reflect across the y-axis, so my x's are going to become the opposite of what they are, so -xy. So if point P is at -3, 1, P prime, the opposite of -3 is a +3, and then my y-coordinate just stays the same. So P prime would be a 3, -1. Number 17. Find the coordinates of the vertices of the image of R, -2, 3, S, -4, 6, and T, 5, -1, reflected across the x-axis. Write an algebraic rule to represent this transformation. So now we're going across the x-axis. It's the opposite of going across the y-axis. When we reflect across the x, my y's are the coordinates that become opposite. So x's stay the same, opposite for the y's. So R prime, my -2 stays the same, my +3 becomes -3. S prime, my -4 stays the same, my 6 becomes -6. T prime, -5 stays the same, +1 becomes -1. 18. The drawing shows triangle ABC. What are the coordinates of the vertices after translation of the triangle ABC 3 units to the left and 2 units up? So you're going to start at each point, count 3 left, 1, 2, 3, and up 2. 1, 2, 3, up 2. 1, 2, 3, up 2. So there's A prime, B prime, C prime. So A prime is at -1, 5. B prime is at 2, 10. And C prime is at 5, 6. Number 19. Plot the coordinates of the image of a triangle with vertices at 1, 5, 7, 1, and 5, 6. So there's triangle ABC. List the coordinates after you reflect the triangle across both the x and y axis. So I'm going to start by reflecting across the x-axis. So point A is 1, 2, 3, 4, 5 away from the x. So we count down 1, 2, 3, 4, 5 to find A prime. B prime is 1 away, and C prime is 6 away. So there's the reflection across the x-axis. So we get 1, -5, 7, -1, and 5, -6. Notice all of my y coordinates are just the opposite of what they originally were. And then we're going to reflect that triangle. Again, we're going to reflect ABC across the y-axis. So now we're going to go to the left. We get A prime, B prime, and C prime. These are going to be double prime because this is our second reflection. So A double prime is at negative 1, 5. B double prime is at negative 7, 1. And C double prime is at negative 5, 6. So for my reflection across the y-axis, my x-coordinates became the opposite of what they originally were. Okay, make sure you bring this to class tomorrow. It is a homework grade. And the test is tomorrow, Friday, February 9th.